with a single inter-stage spray attemperator. Here we can see primary superheater, the secondary superheater. In between the two stages of superheating, we are having a temperator. Spray water is supplied to the attemperator by spray valve, which in turn is being controlled by spray valve controller or secondary controller. Set point for secondary controller is decided by the primary controller. TT stands for temperature transmitter. Since the temperature is in between the two stages of superheaters, the name of the control scheme is steam temperature control with a single inter-stage spray controller. Request. It is hoped that this lecture is going to be useful to you. Please press like. Please subscribe. A cascade control system for superheated steam temperature control with a single inter-stage spray attemperator is shown in figure. Since the temperature of the steam leaving the secondary superheater that is important, this parameter is measured and a corresponding signal fed to a 2 or 3 term controller, proportional plus integral or proportional plus integral plus derivative. In this controller, the measured value signal is compared with a fixed desired value signal, and the controller's output forms the desired value input for a secondary controller. Because the output from one controller cascades into the input of another, this type of control system is commonly termed cascade control. The secondary controller compares this desired value signal with a measurement representing the temperature of the steam immediately after the spray water attemperator. The superheat outlet temperature or primary controller generates the set point of the spray valve or secondary controller as a function of the difference between the final superheater outlet temperature and the manually adjusted set point of the primary controller. Under normal operating conditions, the spray valve controller positions the spray valve to regulate the final superheater outlet temperature to the desired value. A controller with reset action changes its output at a fixed reset rate until the measurement equals the set point. If such a controller is exposed to an open loop so that the measurement can never be made to equal the set point, reset action drives the controller output off scale. This is known as wind up. In a cascade system, when the control valve is fully closed and there is a sustained deviation of the secondary measurement from its set point, the system is effectively open loop. Consequently, the controllers which are equipped with reset action tend to wind up. The solution to the reset wind up problem is discussed in the lecture Superheated Steam Temperature Control Part 2, that is controller saturation effects. Request: it is hoped that this lecture is useful to you. Please press like. Please subscribe.